You know, every time you stream a movie, or you send an email, or even just scroll through your social media feed, you are tapping into this huge, hidden, physical world. We love to talk about the cloud, but we almost never talk about the actual metal skeleton that holds the whole thing together. So today, we are going to deconstruct the unsung hero of our digital age, the server rack. So it kind of begs the question, right? Where does all this stuff, all this data, all this processing power, where does the internet actually live? Because it's not just floating around in the ether. It has a real physical home.
And here it is. The internet, for all intents and purposes, lives right here, inside millions upon millions of these metal cabinets we call server racks. These things are the standardized, super high-density houses that make the modern data center even possible. And they solve a whole series of problems that are way more complex than you might think.
So in this explainer, we're going to walk through how this humble server rack tackles 5 huge problems: creating a universal standard, how to physically mount all the gear, how to keep it from melting, how to control the chaos, and finally, dealing with the human element.
Okay, first up, the problem of scale. I mean, how do you organize thousands of pieces of electronic equipment in one single place without it just becoming a complete, tangled, inefficient disaster? Well, the solution is actually over 100 years old.
Now, you'd probably think the 19-inch rack was born during the computer revolution, right? Nope. Its roots go way, way back to the telephone. Think about it. As far back as 1922, AT&T needed a standard way to cram all their telephone relays and equipment into their offices. And what they came up with was the 19-inch wide format that we literally still use today. I mean, that's just a testament to a brilliant, long-lasting design.
And here's the other stroke of genius: standardizing the height. This is the rack unit, or as everyone calls it, U. It's 1 3/4 inches, and what it did was turn all this complex electronics into simple, stackable building blocks. You got a 1U server, a 2U switch, a 4U storage box. It all just fits together perfectly, like Legos. It's what makes data centers so modular and scalable.
So, okay, we've got a standard size. But that just brings up the next problem. How do you physically secure all this equipment, especially when some of it is incredibly heavy, and you need to be able to service it?
Well, it turns out not all racks are the same. That original 2-post design, it's still around for lighter stuff like networking gear. But for today's massive, heavy servers, you absolutely need a 4-post cabinet. This gives you support at both the front and the back, which is just essential for stopping the gear and the whole rack itself from literally bending under the weight.
And the solution for handling all that heavy gear is so simple, it's beautiful. Sliding rails. These things get bolted into the 4-post rack, and they let a server slide out just like a drawer in your kitchen. What this means is that a single technician can safely pull out a server for maintenance without having to unbolt the whole thing and lift it out. It's just a simple, elegant solution to a really physical problem.
Let's move on to our next problem. Because a rack that's full of servers, well, it's basically a closet full of really, really powerful space heaters. Managing all that heat and the airflow that gets rid of it is one of the most critical jobs in any data center.
The entire system is built on one very simple principle: front-to-back airflow. Servers are designed kind of like wind tunnels. They suck cool air in the front, blow it over all the hot computer parts, and then shoot the hot air out the back. And the entire data center is then organized into hot aisles and cold aisles to manage this flow.
So here's the really crucial point. Maintaining this airflow is a discipline. It's not optional. Putting a server in backwards, that's a catastrophic mistake. But even tiny things like using these little blanking panels to cover up empty slots are absolutely vital. Without them, the hot exhaust air from the back just circulates right around to the front, which contaminates the cold aisle and makes the cooling systems have to work way, way harder.
Okay, so our rack is standardized, it's mounted, and it's cooled. But now we have maybe up to 42 servers running in one single cabinet. How on earth do you control them all without needing 42 keyboards, 42 monitors, and 42 mice?
The answer comes down to 2 key things. First is the KVM switch. That stands for keyboard, video, and mouse. This awesome device lets a technician plug in one console and then just switch between dozens or even hundreds of servers. The second piece is disciplined cable management. And listen, this is not just about making it look pretty. It's about making sure you can actually get to the ports you need and that the cables aren't blocking that critical hot air exhaust.
This simple rule of thumb from sysadmins is such a great reminder that even with all this incredible technology, we're still stuck with the good old laws of physics. And that brings us to our final problem.
The final problem is one of pure mass. I mean, server equipment is unbelievably heavy, and a fully loaded rack can weigh thousands of pounds. This creates a very real danger for the people who have to build and maintain these things.
A super critical distinction here is between static and dynamic load capacity. So a rack might be able to hold 3,000 pounds when it's just sitting there. That's its static load. But its dynamic load, the weight it can handle while you're rolling it around on its wheels, is often much, much lower. The stress of that movement puts enormous pressure on the frame. So you can't just load a rack up to its static limit and expect to wheel it around safely.
And for the technicians doing the actual work, proper lifting technique isn't a suggestion, it's a requirement to prevent some really serious injuries. It's all about planning the lift, getting help when you need it, and always, always lifting with your legs, not your back. Bending or twisting at the waist while you're lifting heavy gear is just a recipe for disaster.
Because a single server node can easily weigh over 60 pounds, installing one often takes a mechanical lift, like you see here. This lets a technician safely and precisely guide a super heavy server onto its rails without risking an injury or damaging the equipment.
So the next time you think about the cloud, I want you to remember this unsung hero. The server rack is so much more than a metal box. It's a century-old, standardized system that provides the structure, the power, the cooling, the control, and the safety we need to run our entire digital world.
And that leaves us with one last thought. The 19-inch standard has served us incredibly well for over 100 years, from telephone relays all the way to AI supercomputers. So, what do you think? What standard is going to define the next century of technology? Thanks for watching.